Good morning, everyone. Welcome to another session on CAT. And today we are going to talk about the topic that you can see on the board. It's ratio, proportion, and variation. So, what do we mean by ratio, proportion, variation? Is basically first understand the weightage of this topic in terms of cat. Whenever you prepare a topic in terms of cat or any other MBA entrance exam, your first priority should be understanding what's the weightage of it and how many questions we can expect. So when it comes to ratio proportion, out of 22 questions from quant, you can expect somewhere around two questions in ratio proportion, and there are few areas where you can easily apply this concept. So like a time and work problem or a time speed distance problem, you can apply this or any other arithmetic area, like even in a simple interest, compound interest, or mixture allocation kind of area. You can see a ratio proportion variation application. So if you understand this topic very well, and there are certain concepts, problems are not very complicated on this, but concepts are need to be understood properly so that you can apply across the areas these concepts wherever it's needed in the questions, like just I said, time and work, time, speed, distance, and other places. With all that, if you see, typically there are these three area: ratio, proportion, and variation. Today we are going to cover the fundamentals of it, and post that we will possibly move on to the next session, which will be covering on the level 1 problems from this area, and the next session will be covering the level 2 problems from this area. So typically our set pattern for any topic in quant, we covered in 3 sessions. First is the fundamental session, that is for ratio, proportion, variation, we are covering now. The next session will be on the level 1 problems of ratio, proportion, variation, and the last session will be on ratio, proportion, variation problem level 2. So that's all. So let's get started without further delay. So first understand, and this is a little concept heavy area, so if you understand the concepts, becomes very clear. um, some of you possibly doing ratio, proportion, variation from your school days, but then there will be a refresher. Along with that, we'll understand some of the techniques or some of the properties of ratio, proportion. So when it comes to ratio, first understand what is a ratio. So if I think clearly, the ratio is nothing but the simplified representation of relation of two entities. So if I say simplified representation of the relation between two or more entities. Now, what do I mean by that? Let's take an example. Let's say has A has rupees 100, and let's say B has rupees, let's say 500. So what's the relation between A and B in the most simplified term? So that's where comes the ratio. I say A has 100, B has 500. So in the same pattern, if I have to say, um, and let's say every day A gets 100 rupees, B gets 500 rupees. In the same pattern, what will be there after 30 days? Now, if every day A gets 100 and B gets 500. So basically, if you understand beyond the absolute values like 100, 500, what's the relation between the money with A versus the money with B? At the most fundamental level, the relation is if you can divide, and that's how we can get the ratio. So we can write A by B is 100 by 500 or 1 by 5. So that means in a ratio we write A is to B is 1 is to 5. This column is read as column is being read as is to, and is to is basically the term that we use for ratio. A is to B, or A and B the ratio is the same thing. So we say A is to B is 1 is to 5, means if A has 1 rupee, B will have 5 rupees. So every 1 rupee A have, B will have 5 rupees. So as per this ratio, if someone says me, A has 20 rupees, can you tell me how much B will have? So I know for 1 rupee with A, B will have 5 rupees. So 20 rupees with A, B will have 20 into 5, 100 rupees. So for 20 rupees with A, B will have 100 rupees. So this is the most common form of ratio confirmation. When you say A is to B is 1 is to 5, that means A does not have 1 rupee or B does not have 5 rupees. So ratio is never a absolute value. So it is never an absolute or actual value. So ratio is never considered as an absolute or an actual value. So it's just a simplified representation. So if A has 1, B will have 5. So it's a representational format. It's not the actual format. So if A has 1, B will have 5. If A has, that means if A has 2, B will have 10, something like that. But this is the most simplified format. So that's why, if you remember, we started with simplified representation. So simplified means this is the most simplified format. When A will have 1, B will have 5. You can say when A will have 2, B will have 10, but that's not the most simplified one. Simplified one is when A is 1, B is 5, and how we achieve it? By dividing this. So this is the main crux of how we are getting the ratio. So if we say A is to B, it's same as written as A by B, right? So how to calculate the values of a ratio? So let's say I said the money with A is to B, let's say I'm saying 2 is to 3. I have given if A has 2 rupees, B will have 3 rupees. Now I say the total money is, let's say, $800, 800. How it will be divided between A and B? So the most common way of solving problems with ratio is how to convert the ratio into absolute number. So convert ratio to absolute number. This is another important area you need to understand. So you need to understand there is something called constant of ratio. We will see similar kinds in proportion variation also, but constant of ratio, which is, let's say you can consider any entity, let's say x, k, y, z, a, b, whatever you want. Let's say x, which is greater than 0. This is not fixed, you can consider any entity. So what does it mean is A is to B, 2 is to 3 means A is 2x and B is 3x. So I don't know what's the value of x, and this is what I'll find out. But from this part, which was the ratio, to this part, which is the absolute number, you need this constant of ratio or anything, x, k, anything which should be greater than 0. And because if it is less than 0, then it defies the purpose of the ratio. Ratio normally does not have a negative sign or negative value. You don't see a ratio being called as -2 is to -3. So it's always on a positive side. So when I say A is 2x, B is 3x, that means I'm converting the ratio value to an absolute value. Now, if I know this, I know this 2x plus 3x should be equal to 800. That means x is 800 by 5 or 160. That means 2x is 320 and 3x is 480. This is the breakup of money with A and money with B. So this is one way to calculate use ratio to calculate some problems. We'll do in the subsequent session on the problems around ratio and proportion and variation. So we will see more of this problem how to solve. Also, the other way is we can say if A and B is 2 is to 3, out of total 5 entities, A will take, for every 5 rupees, A will take 2, B will take 3. That's how we can also read it. So I can say the money with A, if you don't want to go this route of constant of ratio. This money with A will be 2 part of 5 or 2 rupees out of 5 every time, because the total is 2 plus 3. If I do this, it will be 2 by 2 plus 3, because out of every 5 rupees A will take 2 rupees. So out of 800 rupees A will get this much, and this way also will get this is 320. Similarly, you can calculate for B, 3 by 5 into 800, or you can do as 480. This is what you can do. This is another way of calculating the value of the individual value from a ratio. So from ratio, there are two ways to get the absolute value. One is through the constant of ratio. That's what we did here. And the next one is through the to the part method. You say A will take 2 parts out of the total 5 parts. B will take 3 parts out of every 5 parts. So 2 by 2 plus 3, and then you can do 800. So this is another way of calculating ratio. So with this, if the fundamentals are clear on ratio, let's move on to the next area where we talk about some of the properties of ratio. And this is very important in terms of problem solving. And so let's say we say there is a ratio A is to B, right? So there are certain terminologies you should remember. So there is a duplicate ratio. So when I know A is to B, the duplicate ratio will be A square is to B square. So someone says A is to B equal to 2 is to 3. If this is given to me, A square is to B square, which is 4 is to 9. So duplicate ratio of A is to B is 4 is to 9. There is something called as subduplicate ratio, which is nothing but root A is to root B. There is something called triplicate ratio, which is nothing but A cube is to B cube. There is something called subtriplicate ratio, which is nothing but A to the power 1/3 is to B to the power 1/3. So if you know A is to B, you can always calculate all of this. So what very basic ones, but unless you know these terminologies, it may be difficult in a exam setup. So that's why I just covered the terms. So mostly duplicate, subduplicate, triplicate, subtriplicate, you should be remembering. Now there are certain, apart from that, there are certain formulas of ratio. Let's say A is to B is 2 is to 3. Now, if I multiply ratio with one particular entity for both numerator and denominator, my ratio will not change. So this is 1. So A is to B will be same as NA and NB, or same, right? Because I'm multiplying with the same thing. So I can say that A is to B is same as NA is to NB. So basically, if you multiply 2 here, it will become 4 by 6, 2 in numerator and 2 in denominator. So it does not change the ratio. A is to B is same as A is to NB. So whenever you multiply with a fixed number, it will follow, it will not change. Similarly, if you divide with the same number, let's say A by N, A by B will be same as A by N by B by N. Or we can say A is to B will be same as A by N is to B by N. So multiplication and division with the same number will not change the ratio. What will happen in the addition subtraction, we'll see that later. This is one property, that if you multiply with a number, the numerator and denominator both, or both the terms in the ratio, your ratio will not change. This is something you need to remember. Also, there are other properties, like let's say there are two ratios which are equal. So A by B equal to C by D. Now there are few common ratios. So we can also write, this means B by A equal to B by C. So this is called as invertendo. Why it is called as invertendo? Invertendo basically means if you just invert each of the ratios, the denominator becomes numerator, numerator becomes denominator, it will not change. Then we can write A by C is equal to b by d. This is called as alterando. So basically you are just using the numerator from the other side to the denominator and the denominator from this side to the other side numerator. You are altering this. You can also write AD equal to BC, just cross multiplication. It does not have a typical name as such. And then if you add 1 to both the sides, so we can write A plus B by B into C plus D by D. So this is nothing but your component. Similarly, if you just subtract 1 from both the sides, you can also write A minus B by B, C minus D by D. This is called as dividend. So basically, you are subtracting 1 from this. From this, if you are subtracting 1, you will get this. If you add 1, you will get this. So this is called dividend. Or we can say that by combining these two, so there is another formula. You can say if A by B equal to C by D, then we can say A plus B by A minus B, C plus D by C minus D. So this is called as componendo dividendo. So this is called as componendo dividendo. What it is? So if you see typically what is componendo? Componendo is while adding 1, dividendo is while subtracting 1. Now if you just divide this equation and this equation, you will get this componendo and dividendo, right? So if you just divide the what we got from componendo and what we got from dividendo, if you just divide both of them, you will get this componendo dividendo formula. But this is a very, very powerful equation. There's a lot of time you may need to use this. So it's very good to be aware of this such of equations, right? Also, there is another property. It's a property 2. This is A by B is equal to C by D equal to E by F. Then we can write A plus, so all the numerators, E plus D plus F. Again, a very, very important formula. If A by B, C by D is equal to E by F, then all of this is equal to the sum of their numerator divided by sum of their denominator, right? Then there is also another formula. That's it. If A by B greater than 1 and n is a positive integer, then A plus n by B plus n must be less than A by B. You can take any one example. Let's say I take A by B greater than 1, right? So I'll show you an example. So let's say A equal to 5, B equal to 3. So I can say A by B is 5 by 3, or let's say 1.66. Now if I add 1 to both of these cases, so then it will become 6 by 4. If I add 1 in both the cases, it will become 6 by 4. So it's 5 by 3 becomes 6 by 4. If it is 6 by 4, it is 3 by 2, or 1.5. So I can see if I add a positive number to a ratio, to a equation which is more than 1, to a ratio which is more than 1, the equation reduces. Okay. Similarly, I can write A minus n by B minus n should be greater than A by B. Right? This is 1. You can use the same one. If you just from here, if you just subtract 1, you will get 4 by 2, which is 2, which is more than So yeah, you can see this easily. So what we are saying, if a ratio is more than 1, if you add a fixed positive number to the numerator of numerator and denominator, your resultant value should be less than the actual ratio. Similarly, if you subtract the same number from numerator and denominator, or subtract any positive number from the numerator and denominator, then the ratio you will get will be more than the actual ratio. But remember, it will only applicable if the ratio is more than 1. What will happen if the ratio is less than 1? If a by b less than 1, then we can say n is the positive integer. Positive integer obviously has to be more than 0. Then we can say a plus n by b plus n must be greater than a by b, and a minus n by b minus n must be less than opposite. So you can take an example and see this is holding true. So this is another useful law for ratio proportion. Also, if you typically see anything else, okay. Now, if I see there are 3 ratios typically, let's say a by b, which is not equal to c by d, which is typically not equal to e by f, right? And then we can say a plus c plus e by d plus e plus f should lie between lowest and highest ratio among a by b, c by d, and e by f. So basically, what I'm trying to say is, previously we saw if all of these are equal, then all the sum of numerator divided by all the sum of denominator should be equal. Now, if they are not equal, then all the sum of numerator divided by all the sum of denominator should be lying between the smallest value of all these 3 and the largest value of all these 3. So it should lie in between, right? So again, let's take a quick example. So let's say 1 by 2, 3 by 5, and let's say 9 by 10. These are the 3 ratios. So this means 0.5, this means 0.6, this means 0.9, right? So if I add all these 3, 1 plus 3 plus 9 by 2 plus 5 plus 10, so that means 13 by 17, right? So if you do that, 17 by 13, it is 0.7. It should be 0.7 something, right? Yeah, 0.76. So again, lies between, so it is less than, more than 0.5 and less than 0.9, right? So you can understand what we are trying to say. So these are the few properties you should be remembering, which is very, very important when it comes to your that kind of exam. CAT kind of exam. So these are the few properties. So if we quickly revisit, we have seen how a ratio which is less than 1 or more than 1, if you add a fixed number, how it will change. Then we saw just this formula. If 3 ratios are unequal, what will happen if I add the numerator and denominator? Then similarly, some of the other formulas which are more relevant, like a componendo, dividendo, and the equality factor of the ratios, and some of the invertendo, alternando kind of a formula. So this is few things, if you remember from ratio, I think this should suffice in terms of properties of ratio. And this is what you will mostly cover in terms of the problems also. Now coming to proportion. Proportion is called, it's a subset of ratio, because if 2 ratios are equal, they are said to be in proportion. They are said to be in proportion. So if two ratios are equal, so if I say A by B is equal to C by D, that means I can say A, B, C, and D are in proportion, right? So how to write it? So normally they write as A by B with two dots like this. This is the sign of proportion. So if you see this, that means this is a sign of a proportion. So out of this, A and D are called as extremities because they lies at the end, A and D. And if I see B and C, they are called means. So I know from here I can write AD is equal to BC. That means product of extremities, or I'm not writing this, so you can understand. Product of extremities, which is AD, is equal to the product of means, which is BC. This is the only thing you need to remember about proportion, and there is another few terms which you need to remember about proportion. If I say A is to B, C is to D, so this is called as first proportion, second, third, and fourth proportion. So sometimes they will tell you that A, 19, 21, and 23 are in proportion. So you find out the value of A. You just need to use this formula like A by 19 should be equal to 21 by 23. Or they will not tell you this order. They will just say these are the four values. This is the first proportion, this is the second, this is the third, and this is the fourth proportion. So from there you have to form the equation and find out the value of the unknown. Sometimes what this say is A, B, C are in proportion. Or sometimes they may not give you all four values. This is a exception from proportion. They will give you three values and say A, B, C are in proportion, or they will tell you, 3, 12, and D are in proportion. Find out the value of D. So what will happen if A, B, C are in proportion? It basically says A by B is equal to B by C, or AC equal to B square. If three entities are in proportion, then the main one is the mid value, and the first and third one are the first and third proportion. Okay, they might tell you first and third proportion. They will ask you to find out the mean. So that means they have given you A and C to find out B. So this is the formula to use that. So from proportion, we have known two formulas. Is A by B equal to C by D. A and D are extremities. Their product should be equal to B and C, which are called means. So AD equal to BC. This is one formula. The other formula is this A by B equal to B by C when there are three entities, A, B, and BC. So these are the only two things you just need to remember from proportion, nothing else. Coming to variation, let's move on, and we will solve the problems around this, more problems on this to further strengthen your concepts in the subsequent session, where we will do the fundamental problem practice of the concept clarification problem practice session. So when it comes to variation, let's say there are three entities in the variation. What are these three entities? So what is, okay, before three entities, let's understand what is variation. Variation is something I'm saying that, let's say you go from Delhi to Mumbai by road. Okay, it's a long drive. You're going from Delhi to Mumbai. You have, let's say, Maruti 800, right? If you have a Maruti 800, obviously, I don't recommend you to drive Maruti 800 and then in a highway. But let's say you are driving Delhi to Mumbai in Maruti 800. Obviously, your speed will be less. If your speed will be less, you will take more time to reach Mumbai from Delhi. Versus if, let's say, if you are going in a jeep, very, that very nice one, you just bought it in the full flow, it's giving you proper pickup and everything. So speed will be much higher. You will reach Mumbai much faster. So can I say speed, if I increase speed, my time is reducing. We call you, if you have done time speed distance, then you can understand this much. You have seen this earlier. Other than that, it's a common conception. There is nothing you need to know from specifically from TSD, specific time speed distance specifically. You can understand if I increasing my speed in a Jeep versus my speed in a Maruti, my time is reducing because my speed is more. So if there is some kind of relation like this, then we can generally say speed direct inversely proportional to time. So basically, if one entity is increasing, the other is decreasing, that means they're inversely proportional. So this is called as inversely varying. Sorry, not proportion, it's varying, inverse varying. So there is two type of variation, inverse variation and direct variation. So direct variation, let's say in Maruti 800, if you're driving for 1 hour, the distance will be less compared to the Jeep, with the Jeep you are driving. So can I say speed is varying directly with distance? That means if speed is increasing, distance is also increasing. So this is called as direct variation. Okay. So if I write A varies as B, that means A and B are directly, A or B are varying directly with each other. So if A is increasing, B is also increasing. Think of a price of an item. If you increase the price of an item, the revenue from that item you will get more. Then even the cost price is same. There are certain assumptions always. But let's say if you increase the price and there is demand for it, so people are buying less of the item because they can't afford it. So if you increase the price, the number of units you sell may be lesser. So price is increasing, your number of units is decreasing. So price and number of units sold possibly inversely proportional. Price and the profit may be directly proportional. So if you increase the price, your profit will increase typically. Considering other variables the same, I'm not going into that one, but think thus there are two entities, price and profit. If you increase the price, you will increase the profit. And again, think there are two entities, price and number of units sell. So if you increase the price, number of units sell typically goes down. Basics economics. So and this is, then again we can understand. So there are two types of variation. A varies as B, or there is another entity. Let's say A varies as 1 by C. So basically this is inverse. So this is direct. And these are the only two things you need to remember from variation standpoint. What is a direct variation? What is an inverse variation? Now with these two, there is something called as a joint variation. If I have A varies as B, also if I have A varies as C, then I can write A varies as B by C, right? So this is the sign of variances and this is the sign of proportion, like this. So these are the two things you just remember: what is direct, what is inverse, and what is joint variation. That's all. And the final part, what you need to understand from a variation standpoint is how to convert this variation into a equality sign. So we can write this A is equal to K into B by C. Again, K is nothing fixed, where K is constant of variation. You can consider anything, and A has to be greater than 0, not equal to 0. K is a non-zero positive number. Again, ratio portion variation, we don't deal with negative numbers. So K cannot be negative and K cannot be 0. K has to be greater than 0. So you can convert a variation into a positive number, into a equality sign by introducing a constant of variation. So, or K. So let's say I tell you speed is directly proportional to time, and or speed is not directly proportional to time. Speed is inversely proportional to time, and time is directly proportional to distance. So I can say from here S varies as 1 by T, and from here I can say T varies as D, right? So what to write from a joint variation standpoint? So from joint variation standpoint, if you see, we can write D varies as T varies as 1 by S, right? So from joint variation standpoint, I can write D varies speed or you can say um, into time, so speed and time. So we can say, so what we can say from here is your speed varies is 1 by T. So that means I can say speed into time is constant. And from here I can say distance by time is also constant. So this is also another area you can possibly understand. When A varies as B, A by B is constant. When A varies as 1 by B, AB is constant. And so from here joint variation wise I can say D varies as ST. So we can say D is equal to K into ST. So if you know in one iteration, let's say 10-kilometer distance is covered going at 100 kilometer speed in 5 hours or something like that. If you know these individual values of DEST, you can also find out the value of the next iteration where some other thing is given. So also you take another example, let's say price and the demand. So price varies as 1 by D. So if price is increasing, demand is decreasing. That means I can say price into demand is constant. So in one iteration, I know if the price was 10 rupees per piece, your demand was 50 unit. What will be your demand if the price is 20 rupees per piece? So you know this is constant. So I can say 10 into 50 is equal to, let's say this is in the X, so 20 into X. So from here you can say X is 500 by 20 or 25, right? So this way you can do this, use this, and we will see much or many more applications of this in the subsequent session when we do targeted problems on this area. But as of now, these are the three things you just need to remember from ratio, proportion, and variation. So for ratio, there are few properties and few basic concepts. Proportion, again, you need to understand what are the extremities mean, first, second, third, fourth proportion, how three entities are in proportion are kind of working together, and how to write them. And then finally, what you need to remember from the variation is direct variation, inverse variation, and the joint variation, and how all of them converted into a equal to sign from the variation sign. That's about it. I think hope you had a good understanding. You try to revisit this if somewhere you need little extra clarity. If you have any doubt, I will drop my mail ID in the description box, and from there you can reach out to me if you need more help on guidance kind of a thing with me. Please feel free to drop me a note on the mail ID given below in the description box, and we will be able to help you from there. So happy learning. Have a good day.